Hi everyone, my name is Yazan Zamil, a DevOps engineer with a decent experience in the field and hands-on experience on implementing DevOps practices that enabled a successful DevOps culture. I also have a solid background with latest cloud technologies such as Amazon AWS, Google Cloud, and Microsoft Azure. Well, that was a quick introduction about me, but today we are going to discuss about a tool which helps me get my job done as a DevOps engineer. Jenkins is an open source software that runs on a server and it automates some tasks that is used to be done manually by an operation engineer. And now let's discuss what we are going to talk about in this course. So, in this course, we are going to talk about what is Jenkins and why Jenkins, why I'm making this course about Jenkins, and why Jenkins became so popular in DevOps practices. And also, we are going to talk about how to set up Jenkins, what are the fastest way and most reliable way to set up Jenkins. And also, we are going to talk about what Jenkins implements because in DevOps there is multiple practices and one of those practices is continuous integration and continuous delivery. So how Jenkins accomplish those two practices in the field? Before we begin, I wanted to talk about some history about Jenkins. How did Jenkins begin and how it reached here today? So basically, Jenkins was a project called Hewton under a company called Sun Microsystem. And this software was used to automate the builds, testing, and deployment of current software being developed under this company. But after an acquisition from Oracle on Sun Microsystem, the the founder of the Hewton project did fork the project and made it open source. He was worried that this software would be used in commercial uses by Oracle, so he did fork the repository and made it an open source. And now Jenkins became one of the most powerful open source softwares after the community support and how other developers continue to optimize and add features and plugins into
So
that.
now let's basically talk about what is Jenkins and why Jenkins. So basically, what is Jenkins? Jenkins is a software that runs on a machine and it executes tasks. Those tasks are something you define and you write, or you find them in Jenkins tool, predefined for you, so you can use them. And we will look into predefined tasks that are available for you to use on spot. So here we have three components. It's a software, it runs on a machine, and tasks. It execute some tasks. So let's talk about what is this software. So basically, Jenkins is a Java application and it is based on Java programming language. And when we come to set it up, if we set it up manually, we need to have Java installed on our machine or on the server or virtual machine we are deploying on. And it also have an interface. It is a web interface that helps you to navigate into your tasks and into your project. And it's very easy to use and very clear how to set up your project and set up your pipelines, which will execute the CI and CD practices. And it also have plugins. Those plugins save you some time. And we are going to talk about what are some of those plugins. The second part of Jenkins is a machine. So it basically have in its architecture two main parts. It have a controller and it have an agent. And the controller is responsible usually, even in real life or in software, controller is usually have the responsibility to manage the agent, and it's not responsible to execute tasks specifically. It is responsible of managing the agents, and those agents are the ones that are going to execute the tasks we have. So basically, we will have a server and multiple agents Those agents will be listening for this controller or server, and they will execute the tasks that it gave it to them. So maybe a question that may come to your mind, where is Jenkins here? Jenkins will be basically the controller, and the agents will basically be either a virtual machines, other servers, or will be other containers within the same server that Jenkins is running on. But the software will be installed on the controller and not the agents. But the controller will have access to those agents. So I wanted to cut it off here quickly to explain more the concept of controller and agent before we go into setting it up. So let's say you are a DevOps engineer or a cloud engineer. So most of your work would be with virtual machine on either one of the clouds, AWS or Google Cloud or Azure. So let's say you have a big virtual machine and you install, this is the first option we have for setting up Jenkins. First of all, you have a big virtual machine and you install in it Jenkins as one container, and you also run three or four other containers, either Linux or Windows. Usually we will use Linux containers, and you run those containers as an agent and you give them tasks. So this is a little bit of risky to do, because usually if we have all of the setup in one virtual machine on one big and bulk virtual machine with high CPU and memory, other agents might crash and might make our virtual machine to crash, or either in the security perspective, it's better to have them separated. So the better approach is to have one virtual machine, small one, have the Jenkins server running, and we have two or three other virtual machines that acts as an agent, and those virtual machines will be accessed by the controller to give them the tasks that they need to run. So this is the best practices and better approach than having one bulk virtual machine that have all of our containers and our Jenkins server. Third part, which is tasks. What are those tasks? Some common one are version control polling. Basically, a developer have his code on a repository, GitHub, Bitbucket, or Azure DevOps repo, whatever it is. If it's a Git repository, it will be connected to Jenkins, okay? And Jenkins will check out the code based on an event or a trigger. After that, another task is building or compiling a code. If you are a Java programmer, a C Sharp programmer, you would know that before running the application, you need to compile it, and then after it's running it. But if you are a JavaScript programmer or Python programmer, those languages are interpreted languages, and it doesn't get compiled into machine code. They get interpreted into bytecode, basically. And we have another task, which is automated tests. And tests are very important within our pipeline, our CI/CD pipeline, because the application might get compiled correctly and get built correctly, but a developer will define some test cases, and those test cases used to validate which, if the program is behaving the same way that is intended to be behaving, or if it's failing. And we don't want to deploy a program that have bug on it or behaving differently than our requirements. So let's see here a quick picture that illustrates how Jenkins fits into our architecture. First of all, we have a developer, and this developer is writing some code, and after it, he's pushing this code into, for example, a GitHub repository. Once this code gets pushed, there is so now we have a simple architecture which illustrate how Jenkins server fits into the picture in our development lifecycle. First of all, we have a developer which commits the code into a GitHub repository, and after that, there will be defined either a webhook that will trigger Jenkins server, or Jenkins server itself. We can define it to keep it checking in the GitHub repository for any new commits if there is a recent commit or new commit, the Jenkins server will check out the code. If you are a developer, what I mean here is to clone the code, like running git clone. It will clone the latest code or pull the code, and after that, it will assign this code into one of its agent to start running those tasks. And those tasks basically building or compiling the code. For example, Java, you install the required. I'm not a Java developer, so but I have been around seeing other Java developers developing their code and running it. So, for example, you run Maven install, then Maven build, and after that you have some test file. You have test1.java file, test2.java file, and those files will run against your code. And if the all the asserts was correct and there is no failed assertion, then it will pass and get deployed into the environment.